Just like we had a product rule for taking the derivative when we were multiplying two functions, we have a quotient rule which we use to take the derivative when we're dividing two functions. And it looks a little more complicated, but it really works about the same. So the quotient rule says let f of x and g of x be two functions that are differentiable at a, and g of a does not equal 0. And then f of x divided by g of x is differentiable at a, and f divided by g prime of x is equal to g of x times f prime of x minus f of x g prime of x all over g of x squared. Okay, so this is another one that I would encourage you to memorize because it's used a lot. And so let me just show you a little kind of rhyme to help you remember it. So if we label the top function the high one, because it's higher up, and the bottom function the low one, okay, and when we talk about derivative, we're going to say d whatever, either d high or d low. Then the way you can remember this is low d high, so that's why it's the bottom function times the derivative of the top, minus high d low all over low squared. Okay, so low d high minus high d low all over low squared. Okay, so we want to find the derivative of this function 2x plus 5 over 3x minus 2. So this is our f and this is our g. This is our low, this is our high. So the derivative, we're going to do low, you'll do it in parentheses, d high, so the derivative of the top, which here would just be 2, if we take the derivative of 2x plus 5, minus high, d low, the derivative of the bottom is just 3, all over low squared. Okay, and again, you know, if this was just on a test or something, I'd let you leave it like that. But you may want to simplify it to see, is there a simpler answer? So here, if we distribute the 2, we'd have 6x minus 4. And we're distributing a 3 and a minus, so really we're distributing a negative 3. So negative 6x minus 15 all over 3x minus 2 squared. And here 6x minus 6x, those are going to cancel out, and we get negative 19 over 3x minus 2 squared.